Okay, welcome back to another, the second part of the May June 2026 maths paper. Uh, Today, this is the last part, question number 8 till question number 11. Okay, so question number 8 says an arithmetic progression has a first term 20, a common difference d. Geometric progression also has a first term 20 and common ratio r, where r is greater than 0. The third term of a GP is 5 more than the third term of an arithmetic progression. Okay, the fifth term of a GP is 30 more than the fifth term of AP. Okay, find the value of R and D. Okay, so we have to construct a equation so we can solve it. Okay, so for the AP, it uses third term, the third term of the arithmetic progression and the fifth term. Okay, so the third term for it is a plus n minus 1 d, the formula, and a is equal to 20. 3 minus 1 is 2. Okay, so plus 2d. Okay, so we don't have d. D is just a constant right now, so we can leave it. And the fifth term is again a plus n minus 1d. Okay, so which then becomes 5 minus 1 is equal to 4. 4 times d is equal to 4d, so 20 plus 4d. Okay, now for GP, okay, it's again the third term and the fifth term. Okay, so the third term, the formula is a r n minus 1, so 20 times r, 3 minus 1 is equal to 2. Okay, so we'll write that. And the fifth term is again a r n minus 1, which is now 5 minus 1 is equal to 4, so 20 r 4. Okay, we have these now. Now it says that the third term of a geometric progression is 5 more than the third term of arithmetic progression. So now this statement is quite confusing, but we can break it down. And now if you think about it in this way, that first take this statement. Okay, take this statement right now. Okay, this statement says that the third term of geometric progression is 5 more than the third term of an arithmetic progression. So okay, let's give the third term a number. Okay, for example, think of GP third term being okay, maybe 10. Okay, and the AP third term being what? Okay, geometric progression is 5 more, so this one will be 5. Okay, so now if I give it an example value like so if I want to equate them, and make an equation, so they have to be equal. So for them to be equal, I have to do this. Third term of GP is equal to third term of AP plus 5. Why? Because if you look right here, my example values, this is 10. Okay, and this is 5 again. So this is just an example to understand. Okay, so it said that the third term of geometric progression is 5 more, so this is the example, right? So for them to be equal, I have to add 5 to the arithmetic progression. Okay, so we're just going to do that. And again, for the second part, it says that the geometric progression is 30 more, so we're just going to add 30 to the AP. So okay, the first part will be like so, where the GP is 5 more than the AP. That will become third term of GP is equal to third term of AP plus 5. Okay, so we just found it, and it's GP 20 r square is equal to AP 20 plus 2d plus 5. Alright, okay, so 20 plus 5 is equal to 25, so 20 r square is equal to 2d plus 25. Now we can make any of the two the subject, but if I make r square the subject, it will get confusing. Okay, so let me make d the subject. So this becomes 2d is equal to 20r squared minus 25. Okay, so then this becomes we can leave it as 2d because the next part has 4d. Okay, so we can do something. We can just multiply all of this by 2, so we can get 4d. Okay, fifth term of gp, okay, is equal to the fifth term of ap plus 30. So 20r4 is equal to 20 plus 2, and then this equation 20r squared minus 25. Okay, because look here, it's 4d, right? So for this to be 4d, I have to multiply both sides by 2. Okay, so we're just going to do that, and plus 30. Okay, now solve this. So this is 20 plus 40r squared minus 50 plus 30. All becomes 0. So this becomes 20r4 minus 40r squared is equal to 0. Now we can take common, and 20r squared is common. So this becomes r squared minus 2 is equal to 0. Then this becomes 20r squared is equal to 0, and r squared minus 2 is equal to 0. Alright, so this just becomes r is equal to 0. R here is equal to plus minus under root 2, and it can be anything, right? Or there is a restriction. Oh yeah, r is greater than 0 right here. So there's some restriction you have to keep in mind. So r is a positive constant. That means that r is equal to under root 2. Right, that's the r. And now we're gonna find d because we found this equation, right? So 2d is equal to 20 under root 2 squared minus 25, right? This becomes 2d is equal to d is equal to 15 upon 2. Wait a minute, 15 upon 2 or just 7.5. You can write anything. Alright, so this is our answers. Okay, part B, show that the ninth term of the GP is 4 times. Now here it's 4 times, so times 4. Okay. Okay, so we can try to do this now. Show the ninth term of a GP. Okay, now find the GP here. Term 9 is equal to AR8, because AR n minus 1, 9 minus 1 is equal to 8. Okay, so this is equal to 20. We found r as under root 2 power 8 is equal to 20 under root 2 power 8. This becomes 320. And for the AP, the ninth term is a plus n minus 1t. So n minus 1 is equal to 8 times d. This becomes 20 plus 8, 15 upon 2. This becomes now this becomes 80. So it said that show that the ninth term of GP is 4 times the ninth term of AP. So it's basically saying that the ninth term of AP times 4 is equal to ninth term of GP. So is this correct? 80 times 4 is equal to 320, and yes, 8 times 4 is equal to 320. 320 is equal to 330. Hence shown. Okay, now next part. Okay. Okay, this shows a right angle triangle ACD, and AD, this is AD, right? This is AD, is perpendicular to CD. CD is this, AD is this. Okay, and then the arc BE, this arc right here, is part of a circle with center A and 5 centimeter radius. uh, Angle BAE is equal to pi by 6 radian, and the length BC is equal to P. Okay, given that the value of P is 4, so for this part only, okay, for this only part, P is equal to 4. Find the exact parameter. So okay, not in decimals. Give your answer in the terms of pi and under root 3. Okay, so it wants the exact parameter for the parameter of the shaded region, right? Again, this might not be clear to the screen, but the shaded region is this. Okay, right, is equal to r theta is equal to 5 pi by 6. Just keep it in exact form. This becomes as 5 pi by 6. Okay, numerator multiplies each other. So that's that, and now we have to find it. Okay, so now if I make an example triangle here, right, it's like so. This length is equal to 9. Okay, because 5 plus 4 for this part, and this part is not complete. This is 5 till here. This part is 5. Okay, this part is 5 and this part is not known. So we can just use and this week. Okay, and this is 90 degrees, and this we have an idea about pi by 6. Okay, so we can basically use sine. This is hypotenuse and this is adjacent, so we can use cos to find this length and minus by 5, and then we can use Pythagoras theorem for this part. Okay, so okay, we can use, this is hypotenuse is 9 and adjacent is 5. So okay, so cos pi by 6 is equal to adjacent, which is 5 upon 9. Wait, no, we have to find the adjacent. Like, look, okay, this adjacent is AD, and AD is AD. Okay, we're just going to find the exact length, the full length. Okay, AD upon 9. Okay, so 9 goes there, multiplies by pi by 6, cos pi by 6. This becomes AD is equal to, and remember to use radian, okay, in calculator. Okay, cos pi by 6 times 9. Okay, AD becomes 9 under root 3 upon 2. Okay, so now look here. Okay, it needs what? Okay, I found AD. AD became 9 under root 3 upon 2. But I want the perimeter of shaded region, so I want this part. Alright, so this part is all of this length minus 5. So we can subtract 5 from this equation. So this becomes, okay, we want ED, right? So ED is equal to AD minus 5, which is equal to 9 under root 3 upon 2. Under root 3 upon 2 minus 5 is equal to ED is equal to, but okay, we can use, I have to keep it in exact form, so we can take LCM. So this becomes minus 10 plus 9 under root 3 upon 2, I believe. So let me check the calculator. Nine under root 3 upon 2 minus 5 is equal to, yeah, okay, we get this. Now remember this is equation where minus this minus 10, not the whole fraction. Okay, only minus 10 here in the bracket alone. So now we found EB. Okay, we found EB. Okay, we found EB, we found ED. Now okay, these are done, these two, and we know P is BC is equal to 4, so we want to find DC. So we can use Pythagoras theorem. We have 9 under root 3 upon 2 and 9. Okay, so the Pythagoras theorem is such that 9 is the hypotenuse, so this becomes like so: 9 under root 3 upon 2, the whole thing squared, plus c squared. Okay, so then these go there and minus, so this becomes c is equal to under root 9 squared minus 9 under root 3 upon 2 squared, all of this upon under root. So this becomes c is equal to this becomes 9 upon 2. Alright, so here I have left is, okay, these are what we're using, this, and that p is equal to b, c is equal to 4. We're using these 4 to equate, okay? This is e, b, e, d, c, and okay, so let's equate them. Perimeter is equal to 5 pi by 6 plus 9 upon 2 plus 4 plus minus 10 plus 9 under root 3 upon 2. Okay, and please don't get confused, this minus 10 is alone, not the fractions minus. Okay, so don't take this minus overall, this is a positive number. Okay, so if I try to solve this now, 4 plus 9 upon 2 is equal to, okay, this part is 17 upon 2, this part is 17 upon 2, and add with this number 17 upon 2. Plus 9 under root 3 upon 2. Yeah, so I get that perimeter of the shaded region is equal to 7 plus 9 under root 3 upon 2. And wait, that's not full. Okay. Yeah, and then plus 5 pi by 6. And yeah, if I try to join them, this becomes a decimal, so we can leave it in this form. Okay, and yeah, it consists of under root 3 and pi, so this should be correct. Okay, alright, now it says that given instead that the area of the shaded region is this, find the value of p. Okay, now the first part said that p is equal to 4 and find the exact perimeter. So now this is part A, so we cancel this, we don't know p now. Okay, what we know is, let me draw the diagram, and this is this one. Okay, the diagram is such that this is a 90 degrees, this is pi by 6, this part is 5, this part is unknown, and again this part is 5, right, and this part is p, so this part is p, and we have no information about this part. Okay, so here this is A, this is D, and what's that part? Okay, that's C. Okay, and this is C. Okay, so now here the area of the shaded region, this is the shaded region, this part, the area of the shaded region is such that it is this. So we find the equation, that is area of the shaded region is equal to area of triangle minus area of sector. Alright, because this is a triangle, and area of triangle minus this area gives us, of course, the shaded region, and we know the shaded region. So now first of all, Let's try to find the area of triangle alone, because we have the base and height are unknown. Okay. So area of shaded region, sorry, the triangle, 0.2 base times height. We're using base times height because this is a 90-degree triangle, not AB sine theta, not 1 upon 2 AB sine theta. So 1 upon 2, base here is DC and height here is AD. Okay, CD and AD. Now here, uh, here we don't know the values of either. Okay, so we can try to find them by cos or sine or tan. Okay, we know this is 5 plus p. Okay, we know that AC is equal to 5 plus p, and that this is the hypotenuse, and we can find the DC. We can find DC, and because it's the opposite, so opposite upon hypotenuse, sine 5 by 6 is equal to opposite, which we have to find, opposite upon hypotenuse, which is 5 plus p. Okay, sine pi by 6 in radians is 1 upon 2, so this becomes opposite is okay. I think it in this way, opposite. This goes 5 plus p goes there upon times 1 upon 2, so 5 plus p upon 2. Okay, this becomes 5 plus p upon 2. We know this now. Okay, we know CD is that 1 upon 2, 5 plus p upon 2, and we have to find AD. Now okay, AD is we can use cos. Okay, it's adjacent, and we know the hypotenuse 5 plus p, so cos pi by 6 is equal to adjacent. We have to find adjacent, right? Yeah, we have to find AD. So this is the adjacent because this is the angle, this is the 90 degrees upon hypotenuse, which we have 5 plus p. Now in the calculator, I don't think we're going to get an exact value for cos pi by 6. Actually, I'm wrong. I got the answer. So we got under root 3 upon 2. Okay, so 5 plus p times that is like this times under root 3 upon 2. Okay, is equal to adjacent. So this becomes like we can just add multiply them, but this will become, you know, okay, let's leave it in unsimplified form. So 5 plus p, 5 plus p under root 3 all upon 2. Okay, so this is our adjacent, which is our AD. So this becomes like so, 5 plus p under root 3 upon 2. Okay, so how can we simplify this? Okay, first you can see that these, okay, first ignore this. Okay, this you can see both denominators are 2. Okay, so we can just, actually all three denominators are same, so we can multiply the above part. So this becomes 5 plus p times 5 plus p, so this bracket becomes squared. Okay, times under root 3 upon 2. Okay, so this becomes 5 plus p, the whole thing squared, times under root 3. Okay, the whole thing upon 2, because this is 5 plus p and this is 5 plus p, so this becomes squared, and 1 times under root 3. Okay, so this is our area of triangle right here, and the area of sector is, I think, quite easy to find, because you know, area of sector is 5 is the radius, and theta is equal to pi by 6, so 1 upon 2 r squared theta is, area of sector is equal to 1 upon 2 r squared theta is equal to 1 upon 2 r squared theta. So this becomes what? Okay, so this becomes okay. Interesting. Wait, if this is okay, so 25 upon 12 pi is in the question actually. It's given that this is the area. So okay, yeah. So this should be the area of the triangle then. Then this cancels, right? So you can write it down. Okay. So this area of the actually area of shaded region is what? 8 under root 3 minus 25 upon 12 pi, okay, is equal to area of triangle, which is, we just found that, plus p, whole thing squared upon 2 and under root 3 2. Okay, minus all of this minus 25 upon 12 pi, the area of sector. So this just cancels with this, okay. So this becomes what, like 5 plus, this becomes 5 plus p, yeah, 5 plus p, the whole thing squared, times under root 3 upon 2 is equal to 8 under root 3. Okay, yeah, we can find p by this. Then 2 goes there, multiply by 8, so 16 under root 3. So becomes 5 plus p, the whole thing squared. Okay, I can do one more thing, by the way. There's an under root 3 here and an under root 3 there, so we can just cancel them. Okay, we can just cancel them. So this becomes equals to 16 under root 3. Alright, so 16 under root 3 under root, okay, under root this, under root this, okay, under root both sides. This cancels and this becomes what? Okay, yeah, so when finding AC, I have made a mistake here, which is that when I thought this is like they are adding or subtracting each other, but they are multiplying each other, so the denominators multiply with each other too as well. So this becomes 8 actually. This actually becomes 8. Okay, so then in here too as well we can make it 8. Okay, so this becomes 8, and now in here, yeah, no, it becomes 64 actually. And under root 3, by the way, just cancels, so that's also a mistake. So this becomes okay, yeah, 8 goes there, multiplied by 8 is becomes, yeah, 64. So this becomes okay, we take under root on both sides, this cancels, this becomes 8 plus minus 8. So 5 plus p is equal to plus minus 8. So let's see what's the answer. And if it's a negative, we will ignore that because of course p is a length. So p is equal to positive 8 minus 5. P is equal to negative 8 minus 5. Yeah, plus minus, yeah, 5 goes there minus 5. So p is equal to 3 and p is equal to minus plus and minus sign, so this becomes minus 13. And of course this is cancelled, and that the answer is p is equal to 3. This is our answer. Okay, so I just did a minor mistake. I didn't multiply the denominators. So yeah, we can just find the remaining by taking AC as 5 plus p, use cos and sine to find the other lengths. Okay, and plug it in the area of triangle, area of sector, and okay, yeah, the area of sector and in the equation of the shaded region, they are both the same, so we can cancel them. So this becomes yeah, the area of triangle is equal to this, so we can cancel the under root 3's and take a to the other side. This becomes 64 under root both sides, and we get the answer. Okay, this is our answer, p is equal to 3. Alright, question number 10 is about functions. Okay, so here it says that function f and g are defined as follows. Alright, this and this, where a is a positive constant. Okay, a is greater than 0. Find the range of f. Now, okay, so it's better to draw something. It's not necessary, but you can draw it, it's not a problem. So as you can see, the gradient is 3 times, so this will go quite strictly up, and the y-intercept is -6. So we can take this as -6 and goes strictly above, so like so, something like this. Okay. So for y, x is greater than 0, so it wants us to find everything after this side. Okay. So find the range of f. Yeah, so we can okay, x is greater than 0, so the first value of x is what? X is equal to 1. Okay, so we can add x is equal to 1 in here, so this becomes f1 is equal to 3 1 minus 6. This becomes what? Y is equal to 3 minus 6 is equal to -3. So y should be, okay, yeah, so x is going this way, so of course y will go up here. Look, this is our x, it's going this way, and the diagram you can see is going up, right? So in the right side is going up, so of course y will also increase, and this will become range of y is greater than -3, and y only greater, not greater than equal to, because if the domain is we'll copy the domain sign. Okay, so if it's greater than equal to, then we'll use greater than equal to, unless it's just greater. No, in this case. Question 10 part B, find g inverse. Okay, we'll have to copy gx down, 4 upon x minus 3 whole square. Okay, 4x is greater than 3 upon a, by the way. Okay, so for g inverse, first we will make gx equal to y. Gx is equal to y, so y is equal to 4 upon ax minus 3 the whole thing squared. Alright, so here we have to make x the subject, by the way. So I placed their places. Okay, so this comes up here, this goes down there, so this becomes what? Ax minus 3 the whole thing squared is equal to 4 upon y. And if finding inverse, we don't have to really expand the bracket. Okay, that's unnecessary. Take under root on both sides, this becomes ax minus 3 is equal to plus minus under root 4 upon y. Now remember, under root 4 is equal to 2. Okay, so yeah, now here is under root plus minus, and we don't know what it may be. Okay, now here it said that a is greater than 0 and x is greater than 3 upon a. So a is greater than 0, right? So it can be 1 2 3 4 5 and continuous. Okay, so x, the least value x can be is 3 upon 1, which is x is greater than 3. Okay, and if x is a is equal to 2, right? Here a is equal to 1 and a is equal to 2, x is greater than 3 upon 2, which is then means that x is greater than 1.5, right? It can never be negative. Okay, if we take we take a as 6, a is equal to 6, x is what? A is 3 upon 6. Okay, x is equal to 0. Greater than 0.5. Okay, it will become increasingly smaller, like 0.00000 infinity, but it will never become negative. Okay, so always positive. So positive under root 4 upon 5 y. Okay, so this becomes ax is equal to minus 3 to this side is plus 3, so 3 plus 2 upon under root y. This is what we have now, and just take a there and like divide it. So okay, divide by all of this, so this becomes a is equal to 1 upon a, right? We don't really have to expand this, we can just write it down like so, 3 plus 2 upon under root y. Okay, you can just leave it as so, and yeah, this is our g inverse, so we can just replace it. Now g inverse of x, right, is what? 1 upon a, 3 plus 2 upon under root x. So okay, that's our answer. Okay, g inverse is this. Okay, now it says that given that a is equal to 2. Okay, first we can substitute a and everything so we can understand clearly. Alright, gx is equal to 4 upon ax minus 3, so 2x minus 3 the whole thing squared. 4 x is greater than 3 upon a, greater than 3 upon 2. Okay, and it says that g inverse is equal to, solve the equation g inverse is equal to 4. We have to solve this part. Okay, this is going to need gx. Okay, alright, so we know that we found g inverse up there, which was what? G inverse is equal to 1 upon 2, 1 upon a is right, so 3 plus 2 upon under root x. Okay, this is our g inverse now with a substituted. Find okay, solve g inverse is equal to 4. Alright, so g inverse is equal to 4. Yeah, so we can equate all of this is equal to 4. So 1 upon 2, 3 plus 2 upon under root x is equal to 4. So yeah, 2 here is dividing, it goes there and multiplies. So this becomes what? 8. 3 plus 2 upon under root x is equal to 8. Alright, to solve this we can just do this, that 3 goes there. Okay, 3 goes there, minus 8 minus 3 is equal to 5. So 5 is equal to 2 upon under root x. Now I can change it to it becoming this, x is equal to 2 upon 5, and square both sides, this becomes x is equal to 4 upon 25. Yeah, so this is our answer. It was simple. Yeah, okay. Yeah, a is equal to, so just substitute a into the g inverse function and just take half there, so it's 8, and just minus 3 there, so it becomes minus 3. So 5 up is equal to 2 upon under root x, and swap under root x with 5, so it becomes this, and find x. So this is our answer. Okay, now next part, given instead that g8 is equal to 6, find the value of a, justifying your answer. Okay, now okay, before even the question starts, we can see that find the value of a, justifying your answer. Okay, before even starting, I know that justifying your answer means that a, there's going to be two values of a. Okay, and we're going to find one value of a. So this is a restriction. Please be careful in questions. The restrictions are quite hidden. So this is a restriction. Okay, there cannot be two values of a. Okay, given instead that, okay, we can just solve this. First of all, it's that we find g of 8. Okay, g upon, we don't know a, right? We don't know a. So with this being a, okay, so we can find that equal to 4 upon a 8a. We can just write 8a. Ax minus 3, right? So x square. 4x is greater than 3 upon. And I think this domain is going to be the real thing to know about. X is greater than 3 upon 2. This is important right here, please. Okay. Find g of 8. G of 8 is this. Okay. We can't really further solve this, so we can place this in function f. So function f is what? Function f is 3x minus 6. F g8 is equal to 3 x a minus 3 the whole thing squared, 8x minus 3x minus 6, right? So this becomes this, and all of this is equal to what? 6, right? Yeah. So all of this is equal to 6, so 3 upon 4 upon 8a minus 3 the whole thing squared minus 6 is equal to 6, right? So this becomes what, like plus, okay, minus 6 goes there, this becomes plus 6, so 6 plus 6 is equal to 12. Now 12, 3 is multiplying here, it goes there, divided by 12, so this is 4. So what we have is 4 is equal 4 upon 8a minus 3 the whole thing squared is equal to 4. Alright, so the swap places of this and this, so this becomes 4 upon 4 is equal to 1, so 8a minus 3 is equal to 1. And even if I took under root of both sides, this becomes the same. But okay, yeah, let me just write it fully. Square under root, so 8a minus 3 is equal to plus minus 1. Again, we'll get two values of a. Now okay, we can just change them both, right? 8a is equal to plus 3, okay, this goes this side and becomes plus 3, 1 plus 3, so a is equal to 4 upon 8, a is equal to 1 upon 2. Now 8a is equal to plus 3 again, but minus 1, plus 3 minus 1, a is equal to 2 upon 8, a is equal to 1 upon 2 upon 8 is equal to 1 upon 4. Now yeah, this is a big thing here. Now this can't be both. Now he said that justifying your answer, because there must be a singular value of a, not two values, okay? This is a restriction, please understand this. And also again, it said find the value, okay? It didn't say find the values of a, find the value of a. So singular value of a equal to 1 upon 2 and a is equal to 1 upon 4. Now what we can do is actually just substitute a into this, but no, to find a, right? So this is greater than 3 upon a. What if we do this? X is greater than 3 upon 1 upon 2 and x is greater than 3 upon 1 upon 4. What does this become? Okay, x is greater than 6 and x is greater than 12. Alright, we can see that okay, we can see that, look, okay, yeah, gx, yeah, we can see that g has taken the function 8 as x. Here x is equal to, x is to be taken as 8, am I right? So x is equal to 8, so if you look at x is greater than 12, this does not apply. Why? Because if you look at here, yeah, so we used x is equal to 8 here, so if x is greater than 12, so this should not work out. So this is of course the wrong value, right? And yeah, this is the answer. So a is equal to 1 upon 2 is our answer, right? And justifying your answer means, so we can just write that since a is equal to 1 upon 2 is the only value of a satisfying the domain, satisfying the domain or the function, we can say, right? Reject a is equal to 1 upon 4, and also x is greater than 3 upon a, right? So x is 8 given there, so x is greater than 3 upon a. So here, whatever the value of a should be, it should be greater than 3 upon 8. Okay, greater than what? 3 upon 8. 3 upon 8 is what? 0.375, right? So we got a is equal to 0.25 and a is equal to 0.5. Again, this cancels. A is 0.5. Justification is that it meets the requirement for x. Okay, this is how I answer. Now the next part says that, okay, question number 11. Okay, so question number 11 is actually the part that got most of the students. This part was considered the hardest, and okay, if you even find the first parts easier, the part D for this question is the hardest. So we can ignore that, okay, and you can solve this. Okay, this is right. So the last question about coordinate geometry circles. The tangent passes through the points 1, 5 and 4, 4 and meets the circle at point A. So this line passes through 1, 5 and 4, 4 and ends up meeting with the circle at point A. Okay, the another tangent to the circle has equation this. Alright, so we can see that the tangent towards B has the equation x minus 3y is equal to 16, meets the circle at point B. See diagram. Okay, find the coordinates of the point of intersection of the two tangents. So it's basically asking us that to find this thing. Okay, so I've drawn it quite roughly, but I believe they will intersect at such point that y is equal to 0. Their trajectory looks as so. Okay, but we can't prove that. We just have to find the point of intersection of the two tangents. Okay, first of all, we have to find the equation of tangent A. Okay, we have given that we have given that it passes through coordinates 1, 5 and 4, 4. Okay, so we can find the gradient of tangent A, right, and it is what? y2 minus y1 upon x2 minus x1, which is equal to 1 upon minus 3. Okay, we got 1 upon minus 3 as the gradient, and we can use any points, okay, to find the equation. So we can use 1, 5, right? So this becomes y minus y1 is equal to m x minus x1. Okay, so just solve this, and okay, take the 3 here, so this becomes 3y minus 15 is equal to minus x plus 1. Okay, so yeah, okay, okay, it's now open. Yeah, this is plus 1 now. Minus 1 times minus 1 is equal to plus 1. So again, take the multiply 3 there and divide by 3. Yeah, actually we can just keep it in the form where x has a no coefficient. Okay, we can take it as this, because the equation above of B, tangent B, is like so, 3x minus 3y is equal to 16. So we can try that. So x goes here. Okay, so we can take 16. Okay, take 16, minus 15 there, plus 15. So 3y is equal to minus x plus 16. Now there it said that x minus 3y is equal to 16. Okay, so x plus 3y is equal to 16. Take the negative x to here, which becomes positive x. So this is our equation for A, and the equation of B is equal to x minus 3y is equal to 16. Okay, now to find the point of intersection, we can just equate the formulas to come each other. So yeah, x plus 3y is equal to 16 plus x minus 3y is equal to 16. So what happens here is a substitution, sorry, this cancels. Okay, x x plus x is equal to 2x, and 16 plus 16 is equal to 32. Again, x just becomes what? 32 divided by 32 divided by 2 is 16 again. So x becomes 16. Okay. Now x is equal to 16. We can just add it to any equation. Okay. We can add it. So 16 plus 3 plus 3y is equal to 16. 16 cancels with 16, of course, because it goes there and they subtract. So of course y, okay, 3y is equal to 0, and then 0 divided by 3 is equal to 0. So yeah, I was correct. It was on the x-axis. So the point of intersection is therefore 16 and 0. Is that what the question asked? Yeah. Find the coordinates of the point of intersection. Okay. First part is done. Okay. It is given that the coordinates of the circle, center of the circle, are this. Okay. Where a is less than 0. So a is negative. Okay. A is negative. Find the equation of the normal to this circle which passes through point A. Okay, let's try to make a example graph. Okay, so it will be just like so, the circle, like so. Okay, actually this last part could be improved. Sorry. Yeah. Okay, so now we know that this point is what? This point is 16 and 0. And center is somewhere here, with x is equal being negative and on the x-axis. So a and 0. And this is a, okay, not 9. So, and we have points A and B here, A and B. So I wanted us to find the equation of the normal to the circle which passes through point A. So as an example, it would be something like this. Yeah, something like that, because it's 90 degrees to the tangent at point A, and it passes through the center. That's why it asks us to give you an answer in terms of A. Okay, so first of all, the equation of A was x plus plus 3y is equal to 16. Now, okay, what we can do here is that this is the equation of tangent. Now here we can take 3y is equal to minus x plus 16, y is equal to minus 1 upon 3 x plus 16 upon 3. Okay, we can just erase this part. Okay, so this becomes what? 16 upon 3. Okay, so this is the equation now, and the gradient is minus 1 upon 3, so we can just change that, and this becomes what? This becomes the gradient of normal is 3. Okay, now it passes through the center point, so that you can say that it passes through the center. So we can use y minus y1 is equal to mx minus x1. So y is equal to 3x minus 3a. This is our equation. of the normal. Okay, so this is our equation of normal, and in terms of A it's said, so we found it. Now, yeah, sorry, not part D, part C. This is the most hardest question found by the students who took the exam. It is further given that the radius of the circle is under root 40. Find the equation of this circle. Okay, so we can try different things, but let's make everything clear. Write every information we know. Okay, we all know that this point is 16 and 0. We know that this point is the center with point A and 0, and this is okay. Also, we found that this is point A and B. We know that the normal to this curve passes through the center like such, and we also know the equation of it, which is y is equal to 3x minus 3a, and x minus 3y is equal to 16 of b, and x plus 3y is equal to 16 of a. This is the information that we have till now, and now we also got the information that c to a and c to b is equal to under root 40. Okay, we have understood that part, right? So we can solve this equation here because space has ended. All right, okay, so here we can do what? Alright, we can just try different things. Okay, so first of all, we want to know what's the coordinates of A to find other things. To find coordinates of A, okay, first of all, think about it like such, right? This is also 90 degrees, this is also 90 degrees, and this length here, this length is 16 minus A, okay? Because from 0 to 16, but would subtract to A, this is the length. So almost have this like shape here that we can use perhaps. Alright, we know that the normal and the tangent are perpendicular, right? So if we try to equate them, because they touch here as well as yeah, because they intersect here, so we can try that. This is A and the tangent, this is tangent and A, so we can equate them. This becomes x plus 3x minus 3a is equal to 16. Okay, so let's try to solve this thing. So x plus 9x minus 9a is equal to 16. Okay, so 10x is equal to 16 plus 9 upon a. Okay, we have this, and then we can write it as x is equal to 16 plus 9a upon 10. So this is the x coordinate of point A. Okay, so theoretically this is the x coordinate of point A, because we did this because the tangent and the normal intersect, and it intersects at point A. So this is the x coordinate. Now if we try to find the y coordinate, what will happen? Now we can plug it in to the any equation, by the way. So but we can let's plug it in 3x minus 3a minus 3a, so this becomes y is equal to 3 16 plus 9a upon 10 is 3a. So okay, multiply by the numerator. Okay, 16 times 3 is 48, so y is equal to 48 plus 27 so not 21 a upon 10 minus 3a. Okay, yeah, so we can rewrite this as y is equal to, okay, yeah, so okay, think about this. This is, we can use LCM. 10 times minus 3 is equal to minus 30a, so 27 minus 30a is equal to minus 3a. So 48 minus 3a upon 10, 48 minus 3a upon 10. This is our coordinates of a. Okay, now we want to find the center. Okay, so we can take theoretical distances with actual distance. Okay, so we know that this is the equation of a, 16 plus 9a upon, wait, let me write this up here. Okay, so this is our x coordinate. Okay, so I wrote down the coordinates of a, and so we want what? We want to find the center. Sorry, we want to find a, right? The small letter a. Okay, so we know that from C to A the distance should be under root 40. Okay, so we can find okay, C is what? A and 0. So you can find the theoretical and equate it to the actual. Okay, so this is, I think, learned in coordinate geometry, that we want to find something, we can do theoretical. Right, so theoretical is equal to actual, so we can find the theoretical by using the distance formula. Okay, so distance of CA, okay, is what? Is equal to under root. Now under root, then we have what? X2 minus x1, so it's what? 16 plus 9a upon 10 minus a thing square plus y2 minus y1, so we can just write the exact thing because 0 won't affect it. Then thing squared, all of this in the under root, but look, c is equal to under root 40, so again under root 40 is equal to under root, all of this under root just cancels with each other, so this gives us 40. Okay, we can just use the squared here. Okay, so we have what? 16. Now look, 10 times minus a, because we use LCM here, so plus 9a minus 10a, this becomes minus a, so 16 minus a upon 10, the whole thing squared, plus 48 minus 3a upon 10, the whole thing squared, right? So okay, then we can We can perhaps expand this. Okay, 16 squared upon 10 squared. So this becomes what? Let me write up here. This becomes 64 minus a squared upon 25 plus, now here 48 squared is what? 48 squared, let me just do this. 48 squared upon 10 squared, 576 minus a squared upon 25. Again, the denominators are same, so what I can do is make the denominator go to the other side. Okay, this denominator goes to that side, multiply by 40. So 25 times 40 is equal to 1000. So, and we can, okay, let me just do this. Okay, minus a squared plus minus a squared is minus 2a squared. Okay, and we can find that 1000, and 64 plus 576 is equal to 640. So this becomes minus 2a squared is equal to 1000 minus 640 is equal to 360. Okay, 360, and actually yeah, I think I missed something. Actually here. Okay, wait. Okay, so if you look at here, this is squaring this whole bracket, right? So this will apply the identity a square plus b square minus 2ab to these above brackets, and the denominator of course will be 10 squared, which is 100. Okay, 10 squared is 100. So what we can do is here 40 is equal to, now a squared 16 squared, right? This becomes 16 squared 256 minus plus b squared, which is plus a squared, minus 2 times 16 and times a, so minus 16a, and plus all of this plus the second bracket, which is a square, which is 48 squared. So 2304 plus a squared, and then plus 9 squared, sorry. As you can see, this is a 3a, so that's also something. Alright, so 2304 plus 9a squared minus 39 minus 96 a, all of this fraction, all of this upon 100. So 100 goes there, multiplying by 40, which gives us 4000. So we can just first of all do this. Okay, look, now plus minus these things. So 256 plus 234, 256 plus 234, 2304, sorry. Okay, first of all write the thing. 4000 is equal to okay, plus 9 a squared plus 9 squared equals to 10 a squared. Okay, minus 96. Okay, minus 96 minus 16 is equal to minus 112a, and again 256 and 234 is equal to plus 2560. And if you take again 4000 here, this becomes minus 400. Yeah, so this becomes 10a squared is equal to minus, sorry, not equal to, this is on the side. Yeah, a squared, 10a squared minus 112a, and minus 1414 440 is equal to 0. So I did something wrong. Here 2ab minus 2ab, I did 16 instead of 32, and here I did minus 96 instead of another number, I think 288. So let me just fix that and we'll get here again. Alright, so I did some mistakes when expanding these squares. Okay, so this is just that use the identity, because the square is on the bracket. Okay, and 10 is 10 squared is 100, so they have 100 common, and the first bracket squared is this, the second bracket squared is this. So this bracket plus this bracket upon 100, so I take the 100 to go on the other side, so 40 times 100 is 4000, and I just simplify this, so this becomes 10 squared, and this, all this again I simplified again, so I got this. Now we have to use solve this quadratic equation. So let's divide all of this by 10, so this becomes a squared minus 32a minus 144 is equal to 0. Okay, so now we have to see what are the factors. So let's see, 144 divided by 2, 72 and 2, no, 4. Okay, yeah, so the factors would be 4 and 36, and 36 would, no, positive 4 and negative 36, positive 4 and negative 36, 4 and negative 36a 144 is equal to 0, a common, a plus 4, and then again, sorry, minus 36 common. Let's take this minus plus 4 is equal to 0. So a minus 36 and a plus 4 is equal to 0. And of course, in the question, if you haven't forgotten, above here it said that the a is less than 0, so a is negative here. All right, so a is negative, yeah, a is equal to minus 4. This we reject. Okay, we say we reject, and this we accept, like so. And again it said find the equation of the circle. Okay, this is a very long question. I understand why people were very confused. Okay, I don't even have some space left. Okay, a is equal to minus 4. Okay, so we can just write it here. Let's write it here. Okay, so we have a is equal to minus 4. Now it said that the center is minus 4 and 0, and the radius again it said is under root 40. So we know the equation. Okay, it's x minus a whole square plus y minus b whole square is equal to r squared. So this will become x plus 4 the whole thing square plus y squared, 0 doesn't matter, is equal to 40. So again, this is our equation. Finally, this is a very tough question, should have been for at least 7 marks, but okay, 4 marks. This is the working. You have to take the point of intersection of tangent and normal to find the coordinates of a in terms of a. Okay, so when you find coordinates of a, you have to find the distance of CA, because you have given the distance, radius, right? CA is a radius, and you know that it is under 40, so you can calculate the theoretical one with in terms of a. So under root 40 cancels with under root, this and root cancels, so 40 is equal to this, and then you square the brackets by a square plus b square minus 2ab, and all of this upon 100, and take 100 on this side and just simplify. So a we get -4, and this is our equation. So guys, that's the last part 2 for the paper. I hope this helped, and it would mean a lot if you would subscribe and like, because this took a lot of effort and time, so I would appreciate you.